Now that we're done quadratics, we move into trigonometry, and our trigonometry actually will take us 3 units to get through. Rather than one large one, we've broken down the trigonometry into 3 separate sections. So for today's lessons, we're going to review all of the trigonometry that you learned last year dealing with 90-degree angled triangles, with right angled triangles. So we start with Pythagorean theorem. That was our formula. A squared plus b squared equals c squared. And what that means is our area here, the square there plus the square of the other leg is equal to, if you add them together, the sum of the square off of the hypotenuse. And the reason that this is important, or the reason that this helps us, is that we can find side lengths when we don't know them and may need them. So let's just look a little bit closer at our example here. If we had a side length of 3 units, right there, side length of 3 units, and a side length of 4 units, if we squared those two, 3 squared is 9 and 4 squared is 16, and added them together, it would equal the sum of the other side. So if we square root them, we can get the lengths of the triangle if it has a 90-degree angle. Okay, so then we can use this to find unknown side lengths. So let's look at our first example here. We have a leg, one of the sides is 5, and the other leg is 12. So we always start by showing our formula first. Those communication marks are really important on your tests and assessments, so be sure you start there. A squared plus b squared equals c squared. Now the 5 can go into either the a or the b. Either of those legs, those can be reversed, 12 squared, but it's really important that the c is always the hypotenuse. So we have to be sure that we don't sub a number in there right now, because that's what we're looking for. So if we square these and add them together, they equal 169 equals c squared. In order to isolate for c, we need to square root both sides, and if we do that, our answer is 13. So our side length here is 13 units. It doesn't specify whether it's meters or centimeters, so we can just leave it as such. Let's look at one more example where this time we know the hypotenuse, but we're trying to solve for one of the legs now instead. Again, I start with my formula, and I substitute the 9 into a squared. You might substitute it into b squared, and that's just fine, as long as that 15, the hypotenuse, always goes on the right side of the equals. And now we just have some algebra and some isolating in order to be able to solve. We square root both sides, square root the b, square root the 144, and our answer is 12 units. So the side length b here is 12 units long. So our Pythagorean theorem is very helpful if we need to find unknown side length, but Pythagorean theorem doesn't help us if there's an unknown angle that we're trying to solve for. If you look in our diagram here in this question, there's a theta, and that theta means unknown angle. So sometimes we'll know side lengths, and by using trigonometry ratios, we can find unknown angle. A review of our trigonometry ratios here are 3 up here: the sine, cosine, and tangent. So sine says that if you know the length of the opposite side and the length of the hypotenuse, you use that. So we often show it in short form that you have sine equals opposite over hypotenuse. Our cosine is, if you know or are looking for the length of the adjacent side and the length of the hypotenuse. So our cos, in short, is a over 8, h, the adjacent side and the hypotenuse side. Our tangent is the length of the opposite side and the length of the opposite of the adjacent side. So we have O over A. Keep in mind, opposite is exactly what you're thinking, directly across from you or directly across from the angle. And adjacent means when you're next to somebody. So if you have an adjacent side to the angle, it means that it's next to it. Our diagram here clean that up, illustrates that as well. So if we're looking for theta, this is our adjacent side and this is our opposite side. If something happens that we decide to look for angle B instead, let's do a little sketch here. If we decide to move theta up there and look for that angle, this side is now the opposite side and this is now the adjacent, opposite to the angle next to the angle. So now let's actually see how to calculate these. So in this example here, it says to solve for angle A. So that means that's our unknown angle. If that's it, then the 5 is the adjacent side and 10 is the hypotenuse. The side always across from the 90-degree angle is the hypotenuse. The hypotenuse is always the longest side in the triangle as well. So if we know the adjacent and we know hypotenuse, and we remember our SOHCAHTOA, just highlight that here in the note part. So if we know adjacent and hypotenuse, that's where the A and H shows up. So we're going to use our cosine ratio. So we have cos theta. Again, we're going to show our formula first, so our work is communicated properly. So cos theta equals adjacent over hypotenuse. So cos theta is 5 over 10. And remember that algebra is always about doing the opposites. So I need to take the inverse relation of cosine on the other side, the opposite, in order to find for unknown angle. Anytime you need to find an angle, you will always use the inverse buttons on your calculator. So when you use your calculator, and be sure that you pause the video right now and do that, and see that you're getting 60 degrees. If something happens that you're not getting 60 degrees, remember to check on the screen of your calculator and be sure that you're in degrees mode. Our next example gives us the angle this time, but we're looking for side x. So if we're referencing angle 51 degrees, the opposite side is x, and that's what we need, so it has to be in the formula so we can solve for it, and hypotenuse. So when we're talking about SOHCAHTOA, the O and the H shows up with the S, so we're using the sine ratio. So we have sine 51 degrees equals opposite over hypotenuse. Sine 51 equals x over 9. Then our algebra says that we have sine 51 multiplied by 9 equals x, for a final answer of 6.99, or rounded up to 7.0 feet, is x. Whenever it gives you the units in the question, be sure to use the units in your solution for your communication marks. The last thing I want to draw your attention to is two terminologies, angle of elevation and angle of depression. And the reason you need to know these is they're going to show up in your word problems when you're trying to solve questions with 90-degree angles. What's really important to remember is that your angle of elevation and angle of depression always comes off of a horizontal line, never a vertical line. So you can see here the angle of elevation means that this angle is opening up, and it's off of a horizontal line here, okay, down here. So for angle of depression, our angle is opening down, and it's still coming off of a horizontal line. Our horizontal line is here. Sometimes when you're drawing a question, you might need to draw that horizontal line in yourself in order to be able to solve a problem. So just be sure that you always have it coming off of a horizontal. That's it for today. We'll practice these questions tomorrow in class.